Hello friends, today we will see single pole system, frequency response and step response. So we will start. Okay, so single pole system, frequency response. So now single pole system is given by 1 divided by s by omega p. Omega p is pole frequency, so this can be represented by magnitude and phase response. Now magnitude of this transfer function is given by 1 divided by square root 1 plus s square upon omega p square, and phase is given by tan inverse imaginary part upon real part, which is given by tan inverse omega upon omega p. So we can represent single pole system by magnitude and phase. Now in dB scale, how we represent magnitude? So this is magnitude. So in dB scale we write it as a 20 log HS dB. This is on dB scale. Okay, now we can write it like 20 log 1 plus s square omega p square. So this is on dB scale. Okay, now let's consider different cases. So case 1, when omega is we consider first when omega less than omega p. So how it is going to impact magnitude in dB? So this will be 20 log 1 square root 1 plus, so this will be omega square omega p square. Okay, let me correct one thing. So this is omega square, here it is omega square. Now omega upon omega p from here less than 1, so we can write it like a 20 log, and so as compared to 1 we can ignore this term, so it will be 1 equals to 0 dB. Now let's consider case 2. When omega equals to omega p. So frequency in dB, magnitude in dB given by 20 log 1 square root 1 plus 1 equals to 20 log 1 by square root of 2. So this will equals to minus 20 log square root of 2, and it will come minus 3 dB. So at omega equals to omega p, our magnitude is minus 3 dB. Now let's consider case 3, when omega is much greater than omega p, omega upon omega p much greater than 1. So magnitude is given by in dB, again 20 dB. 1 second. 20 log 1 by square root 1 plus omega upon omega p square. So this we can write as 1 square root omega upon omega p square. So we can ignore 1 because omega upon omega p much greater than 1. So 20 log omega p upon omega. So now we can say that it is a linear equation. How? hs dB 20 log omega p minus 20 log omega. Okay, now in this consider two frequency omega 1 omega equals to omega 1 and omega equals to omega 2 and omega 2 equals to 10 times of omega 1. So hs dB, so this is say omega 1 minus hs dB, this is at omega 2. When we subtract this, we will get my 20 dB. So it means when frequency is increased by 10 times, then magnitude is reduced by 20 dB. So we say that this is say omega 1 frequency, say this is omega 2 frequency. So say this is omega 1, this is omega 2, and if this is say some gain, say some A, then here gain will be A minus 20 dB. So this is 10 cross omega 1. So this is roll of minus 20 dB per decade. Okay.